day. Today we are going to consider one of the most important topics in mathematics, and that is trigonometric ratios. Mathematics is the subject. Mathematics is the subject. And the topic we're going to consider is the trigonometric ratios. Trigonometric ratios. That's the topic we are going to consider. We can study the concept of trigonometric ratios using a right-angled triangle given as false. Right-angled triangle. This is a right-angled triangle with angles capital A, capital B, and capital C, right? The angle sustained by capital C is known as the theta, while this is a sign for right-angled triangle. All right, then we have three sides. This side is the longest or the greatest side in terms of measurement and is known as the hypotenuse. We are going to use B, small letter b to represent it because it's facing the bold letter B. So this side is known as the adjacent, and we're going to use small letter a to represent it because it's facing the angle capital A. Another side is this side. This side is the opposite, and we're going to use a small letter c to represent it because it is facing the angle C or theta, so small c. However, this means that the names A is the adjacent. Adjacent. This side is called the adjacent, while this side B is called the hypotenuse. Hypotenuse. Then this side C is referred to as the opposite. Opposite. All right, having said that, in order to find or analyze the relationship between these three sides, we are going to use a simple concept known as the SOHCAHTOA. Simple concept known as SOHCAHTOA. How do we mean by this concept? It simply means a concept that will help us to resolve trigonometric ratios. So for this the first, the second, and then the third, right? So here, x stands for sine theta. Each of the letter will go with the angle we are referring to. Sine theta, that is what? Opposite, okay? Over hypotenuse, okay? That's the meaning of this. Opposite over what? Hypotenuse. All right. So that's the first thing we are going to do to make sure we get this. And once we get this, the next thing we consider the second one, which is the cos theta. Cos theta is given as a adjacent. A represents adjacent over hypotenuse. Adjacent over hypotenuse. Okay, just half. And then we go this that way. Then the next one is TOA. Okay, SOHCAHTOA. So the tau here means tan theta is equal to what? Tan here is opposite all over adjacent. Opposite all over adjacent. That is it. Alright, having known this, the next thing we are going to do is to represent each of these relations or ratios with their various letters. So for sine theta, we have opposite over hypotenuse, okay? Opposite over hypotenuse, that's what we have. So for opposite is C, hypotenuse is B. C all over B. Then for cos theta, we have adjacent over hypotenuse, okay? So adjacent is A, hypotenuse is B. Then for tan theta, we have opposite over adjacent. Opposite again is C, adjacent is A. Alright, so you can see we have done very well here. So that's the summary. Then the next thing we're going to consider is other aspects like cosecant theta. Cosecant theta simply means inverse of what? Cos theta. That's the meaning. Cosecant theta simply means the inverse of cosecant theta. Sorry, simply means the inverse of sine theta. That's the meaning. The inverse of sine theta. While secant theta simply means the inverse of cosine theta. Secant theta simply means the inverse of cos theta. Alright, so you can see that simplifies it. The next thing we are going to consider is cotangent theta. Cotangent theta or cot theta. Cotangent theta, or you call it cot. Cot theta simply means the inverse of tan theta. Okay, with this, that means we have really gone far with this, okay? We have really done well. We now have the basis of what we want to apply in solving one of two trigonometric questions, okay? Now, the next thing we are going to do is to look at how we are going to apply this. We consider a particular question and then try and see how we can use it to resolve this question. All right. Okay, so that is it. Now, an exercise presents itself. We have problem one. Given that sine theta is equal to 8 all over 17, comma, evaluates the following. Evaluate the following. Okay, that's the question. The question is very simple. Given that sine theta is equal to 8 all over 17, evaluate the following. The first thing we're going to evaluate is cos theta. The second we are going to evaluate is tan theta. And then the next one we are going to evaluate, the number 3 question we are going to evaluate is cos theta minus sine theta all over cos theta once again plus sine theta. So we can see the question. This is problem number 1. Problem 1. So we are expected to solve this using trigonometric ratios, okay? Having built the basics, we can solve this immediately. All right. So we need our solution. We take from this point. We take our solution from this point, okay? We can consider our solution from this point, and then we solve down. Solution to P1. P1 means problem 1. Solution to P1 simply means solution to problem 1 that we have here, right? So what we're going to do is, first of all, we state the question. The question is sine theta is given as 8 all over 17. So what do we do? What it means is that comparing this, sine theta is equal to opposite over hypotenuse, that is C over B, C all over B. Therefore, the value of C is 8, comma, the value of B is equal to 17. With this, we now consider redrawing the right angled triangle. Once again, let's see the side that we are looking for. So if we redraw, we have a right angle triangle, okay, we have this. All right. So we have C, we have A, and we have B once again with the angle theta. Okay. The opposite is given as 8, hypotenuse is given as 17. Then later, that is the adjacent side, is actually the side we are looking for that will enable us to solve this question. Okay. So how do we go about this? By simply applying Pythagoras theory. Using Pythagoras theory, theorem, we obtain this. Alright. Using Pythagoras theory, let's see what we're going to obtain. So it's now time for us to clean this part of the board and then create some space where we'll now write all these things accordingly. So Pythagoras theory, we have this. That is it. It's given as b squared is equal to a squared plus c squared. This is the simple statement of Pythagoras. So, but here we are looking for what? The side adjacent. So looking for adjacent, it means we are going to make A from this Pythagoras theory the subject of the formula. So we have A squared is equal to B squared minus C squared. Further, we have therefore A is equal to root B squared minus C squared. Alright, this is the formula we are going to apply now. We substitute accordingly. In place of B, we substitute 17 and then square it. In place of C, we substitute 8 and then square it. You can see C is 8, then B is 17 in value. Alright, so the next thing we're going to do, we continue. Simplify further. 17 squared will give us 2, 8, 9. Yes. Y 8 squared will give us 64. 64. Then the next thing is a simple, we consider the sign there. That is a subtraction sign. 289 minus 64 will give 225. And the root of 225 is simply 15. 15. Therefore, A is equal to 15. Right. So this side has been found. A has been found to be what? 15. We'll move on. From there, we'll move on again. That is it. We'll move on. Okay? Having found the value of A, we can now go ahead and get cos theta. Question number 1. Cos theta is given as what? What's cos theta? Cos theta is given as cos is adjacent over hypotenuse. That is A all over B. Okay. I think it's time for us to clean all this. All this. We can still leave the question. Okay? Problem 1. Okay? We can still leave the question. Alright. So, that is it. We substitute accordingly because theta is equal to, for A is 15. Okay? The value of A is 15. We put 15. The value of B is 17. So, this is actually the value of cos theta. Done. Very simple. We have used trigonometric ratio to find the value of cos theta. The next thing is a second question. Tan theta. Tan theta is what? We check again. Tan theta is TOA. That is opposite over adjacent. Opposite over adjacent. So opposite over adjacent is C all over A. Right? That is it. Opposite over adjacent is simply C all over A. Then we move on again and substitute wisely and accordingly. For C, the value of C is 8. The value of A is 15, as we found earlier. So we have solved this now. And that does it. Now the question number 3. That's this whole beddage. Look at this, look at this, look at this. Look at this whole beddage. That's what we're going to resolve now. So we have to consider cos theta minus sin theta all over cos theta once again plus sin theta. That's what we're going to resolve, as we have seen. Alright, that's what we're going to do, as you've seen now. So we'll move on. With this, cos theta is giving us, we take it up. We're taking it from here up. Cos theta is giving us 15 all over 17 minus, because there is minus there, right? Then sin theta is giving us what? Where is sin theta? Sin theta is giving us 8 all over 17. That's okay. That's the numerator. We are done with the numerator, right? We are done with the numerator. So the next thing we're going to consider is the denominator, which is this. Cos theta again, we maintain 15 all over 17. This time around we have plus sine, right? Then sin theta, we maintain 8 again all over what? 17. Okay, simple board mass rule. Simple board mass rule. Okay, we now have to clean this. Okay, we have to clean this. Right, simple board mass rule. We apply simple board mass rule. Okay, board mass rule. Yes, we applied simple board mass rule, or simple board mass. Either you call it simple board mass rule or simple board mass. So we move on and say, okay, all right. We find the LCM of the numerator. First of all, we find the LCM of the numerator, and the LCM is just 17. And then we will now operate with the sign there. That's minus sign. 15 minus 8 will give 7 all over. Okay. We now find again, once again, the LCM of the denominator. Still what? 17. And then we say 15 plus 8 we give 23. 23. Alright, the next thing we're going to do is very simple. 7 all over 17. Normal, okay, simple board mass rules. We have 23 all over 17. This implies 7 all over 17 times 17 all over 23. That's simple board mass rule, okay? You can see that 17, we take care of itself, 17. And we are left with what? We are left with 7 all over 23. That's all. Alright, so that's the answer to all this. You can see? So it means, therefore, that cos theta minus sin theta over cos theta once again plus sin theta, alright, all boils down to what? That gives what? 7 all over 23. Okay, so that is it. Final answer. Final answer to that. Alright, so that is the final stage in resolving this, okay? Thank you very much for your time. I want to use this opportunity to invite you to like our Facebook at Kingsley Levi Ede, facebook.com. I really want you to subscribe to our channel, YouTube channel, and then visit us, or rather follow us on Instagram, Pinterest, WhatsApp, Twitter, and so on and so forth. Thank you for your time.